Okay, so we are going to start with the algebraic identities today, which will help us to do the factorization. So first of all, once more, we will review the identities what you got. One day I have written in previous video, but still now once more I'll be writing it, right? So that we can go for a review. You also note down these things because these are important, right? I'll start with the very first identity you got in class 8. It is x plus a into x plus b, that is equal to x square whole into, sorry, x square plus a plus b whole into x, and then this is ab, number one. So I'm going to take the problems together here, right? So that identity wise we can be able to finish the exercise. I'll not pick up the direct problem of the exercises. Exercise is totally your homework, right? Okay. So now here example I'm taking. In terms of example I have taken. Suppose somebody told you to multiply this, say x plus 3 and x minus 2. So here just you try to compare what are the basic things. X and x, it can be compared here. Right here these two are plus, but here it is minus, no problem. We will adjust this minus, just I'll explain you. And this is the value of a, this is the value of b. So first we will put them in the given format and then we will be applying the result. So x plus 3 and then this will write as x plus minus 2. Now very well you can identify that this is the value of a and this is the value of b. So in that case directly you can write the result as x square, then here it is the place for a plus b. So a is 3 and b is minus 2. So I can write it like this. And then this is a into b. So what will be the answer? It is x square. Then this is, okay, the x I have missed. This is x. And then this is minus 6. Now we'll go for number 2. Example number 2. What if in both the cases there are minus? It can be happening, right? Say it is 1. So in that case, you can do it directly also, but what we'll do is like this. So this will be x square, then minus 2, minus 1, x, and then this is minus 2 into minus 1, giving you the answer as x square minus 3x plus 2. Right, so this is the answer here. So just you try to adapt the identities. I'm going to do plenty of questions with every identities so that book questions you can do all from your side. This is one. If this is, sometimes it may be like this also. You should be able to visualize this. Suppose twice x plus 1 into twice x plus 3. This time what has been done is there is a small modification. In place of x, this quantity is twice x, right? So this time mentally you consider that as x and you apply the result. So it will be what? In place of x, you should write twice x, so twice x whole square. Then in place of a, it's okay 1, b it is 2. Then here it will be twice x, and then this is a into, sorry, it is not 2, it should be 3. So 1 into 3. So what will be your result? It is 4x square. Then it will be 8x, and this is 3. Likewise, you can do, right? You may be getting this also, right? Now you try to see once more. I'm going to do another problem. Now that can be a trick for you. Suppose I'm giving you two polynomials like this, two monomials like this. This is 2x plus 1, and this you have to write. right? And then you have to apply the identity, suppose. So how you will do, you see, in both the cases, right? In both the cases, there is a problem. It is x, it is twice x. But to apply this identity, you should get both to be x. So we have to do this to be x. So from here, what I'll do, you see, I can take it 2 common. If I take 2 common, this will become half, and it is already x plus 3. Very nice. Now let the 2 be outside and treat this particular part as you did for the original one. So it will be x square, then it will be half plus 3 whole x, then half into 3. And then you simplify and multiply 2 at the same time. I'll do one more step. So it will be x square. If you add them up, it is 7 by 2x, and this is 3 by 2. And now you multiply. So your answer is 2x square plus 7x plus 3. That's it. So you can apply the same identity in a modified version, right? Now we'll take that kind of problem only. Let me see what was the problem question number. It was 4. So now we can have numbers here. We can have numbers here. Suppose somebody told you that you have to multiply 98 into 97. So what you have to do, you take a number which is containing more number of zeros and close to both 97 and 98. So I'll be getting this as 100 minus 3, 100 minus 2. So now you can easily treat that this is x and this minus 3 will be a. So one more step I am writing so as to put this exactly in the pattern what we have in the identity. Okay, so now easily you just try to see, you need not write this. This will be x, this will be a, this will be x, and this is b. So it is x plus a into x plus b type. So your identity will show you first this is x square, then plus a plus b. A means minus 3, b means minus 2, they are to be added, multiplied by 100, and then a into b. Great. So now this you have to simplify. So now this is 500 and this is plus 6. This calculation you have to do. It is 10,000. So 9,500, 9,506. So this is the answer. Likewise we can go, right? So I'm doing continuously. So once I finish this board, then I'll ask you to write. At the same time, you go on writing also if it is possible. Now sometimes it may be like this also. Say 97 and 101 they are asking you to multiply. So what you can do? Now you got the trick. It is 100 minus 3 and then 100 plus 1. So now just if you want, it is not necessary that always you should put it in the standard form as I am doing here. Now because you are going to be an expert here, so you may not write this particular step what now I am writing, right? So we have written this. So now here, then again what we can do, we can consider this to be x here and this to be a, this to be b, right? So in that case what we'll get here is it is x squared, that is 100 square, then plus value of a is minus 3, value of b is 1, then I should multiply here 100, and then this is minus 3 into 1. So your answer is 100 square means this is 10,000, then this is minus 200, and this is minus 3. So it will be 10,800, but it will be, sorry, 9,800, 9,797. So this is the answer. See the calculation. If I did a mistake, I should not do the calculation mistake here. 9800 minus 3 will give you Here 7, here 9. It is, yes, correct. So now next problem is, let me consider only one of this kind. 102 into 105 zeros. So this I can write as 100 plus 2 into 100 plus 5. So now as usual, you can easily see that this can be treated as x, this can be treated as x, this is a and this is b. So with the help of that same idea, we can write this as x square, then a plus b, this is x, and then a into b. So you'll be getting this as 10 squared, 100 squared, that is 10,000. Then this will be 700, and this is 10, 2 into 5, 10. So it will be ultimately 10,710. Sorry, I made a mistake over there. 10,710. 10,710. So this is the answer. So please note it. Now I'll pick up the number 2 identity. This also you got earlier. That is a plus b whole square is equal to a square plus twice ab plus b square. Two identities together I want to take because they are like brothers and sisters. A minus b whole square is equal to a square minus twice ab plus b square. So I'll give you a quick proof of this also so that you will be comfortable. It is not asked, but still I am saying. So left side is a plus b whole square. That means a plus b into a plus b. So now by binomial, if you multiply another binomial, so with this I have to multiply this completely. So I can write like this, and then b times a plus b. That means with this I multiplied completely these things, and then with this. So you'll be getting this as a square, this as ab, this as ba, b square. So combining them, you will be arriving it here, and it is nothing but the proof of the identity. In the very similar manner, if you go for the proof of this, so it will be a minus b into a minus b. Idea is same. With this a, I have to multiply this completely. So it is a minus b. With this b, but remember there is a minus sign b, so that will come here, and here it is like this. Okay. So now I'll be getting this as a square minus ab. Now see, there is a minus sign in between. Very careful about this minus sign, as there is a minus sign here. So you must be very careful in writing the expansion here. This expansion should be written because of this minus inside the bracket. Otherwise you may commit a mistake. So b into a, it is ba, and then b square. Now you remove the bracket. So it is a square minus ab minus ba plus b square. Now you collect and you get the required expansion, that is a square minus twice ab plus b square. So you arrive at the formula. So now these identities can be used for doing many expansions. I am doing some of the expansions because that may be asked, right? Now I'm going to take the examples. Examples. So number one, they will ask you what is it expand. Your question will be simply expand. So what I can expand is, suppose somebody tells you that you have to expand distance. So make use of your idea, observations, right? Your observation must be very strong. This whole thing I'll compare as A, this whole thing I'll compare as B, and in between there is a sign X. So very well you can compare the whole problem with the identity A plus B whole square. So directly you put it. This is the place for A square, right? So I have to put this in the bracket because Square 3x
Sir,
is that? Yes.
sir, can you dictate the question?
Which one? It is
Sir, which one
3x.
you?
3x plus y whole square.
3x plus 1 is. Thank you, sir.
Okay. So now this is a square. Then I should write from the formula twice ab. 2 I have written. This is the place for a. This is the place for b. So I will write here a and this is b. And here this is a place for b square. So now if you follow these things without any deviation, then you will never be correct, never be wrong. So 3x whole square matlab 9x square. Then this you can know multiplying 2 into 3 is 6 and then xy and then this is y square. This is y square. Okay, so now we'll be taking another one, number 2. More of the times expansion will be like this only. So suppose I want to take an expansion of this kind. Somebody tells you to expand 2x minus 3y whole square. So here also you have to be clever enough to identify that you are going to do the expansion of this one. Here this will be treated as a, this will be treated as b, and in between minus sign you can see. So that way you can easily treat. This will be the place for a square. First, preserve the place for AB by putting a bracket. Then I can assure you that you will never be committing any mistake. A square is there, then 2. This is the place for A, this is the place for B, and then plus this is the place for B square. So now you go on putting, in place of A, you should put twice x. Here also twice x. In place of B, you should put 3y. Here also it is 3y whole square. Now simplify and just arrive at the result. Now it will be 2 2 0 4, 4 3 0 12, and then xy, and then 3 square will give you 9 y square. So that's the result. That's the result. Now number 3. In this number 3, I'm going to take a number. Right? Suppose somebody asks you, actually these things you got in class 8 only, but still it's a review we need to do. 100 plus 2, sorry, 102 whole square. So 102 can be written as 100 plus 2. So already you know why we have chosen 100 plus 2. You could, someone might choose 95 plus 7 also, but that will not be good thing because here you have to do the square of 95. So 95 square you cannot do orally. So that's the way why we have chosen more number of zeros after 1. So now you can treat this as A, this as B, and you can apply the formula. So this is the place for A square. 2, this is the place for A, this is the place for B, and this is the place for B square. Now you go on giving the input, and I can assure you that you cannot do any mistake if you do like this. So in that case, it will be 10,000, then it is 400, and this is 4, and you add the result, it is 10404. Great. So this is the result. Likewise, if I ask you to do say 98 whole square, so here what we'll do, it is 100 minus 2 whole square. Now this is a minus b whole square. So this is the place for a square minus 2 a. This is the place for b, and then this is plus b square. So you go on putting the values. This is a, that is 100. This is 2, that is b. Now you work it out. This will be 10 square, that is 100. Sorry, 100 square, that is 10,000. And this will be 400, and this will be 4. So your answer will be 9,604. 9,604. So now I'll be taking just one or two more problems of this identity because this already you understood. Number 5, suppose. Sometimes what happen, you may encounter problems like this also. Say 1 by 3. Maybe you can get this. So no need to worry for it. Again, idea is same. Again, idea is very much same. There is no deviation. This whole thing you can consider as A. This whole thing you can consider as B. and in between you can see that there is a sign which is plus. So you have to use here a plus b whole square. That's all. It's very, very clear. So this is the place for a square two times. This is the place for a, this is the place for b, and this is the place for b square. Now just give the input. A is half x, here also half x, 1 by 3y, 1 by 3y. So now you simplify half x whole square, matlab 1 by 4x square, 1 by 4x square, and then you can cancel this 2 here, then it will be 1 by 3 xy, and next one is 1 by 9 y square. So now here just one minus I'll take so that you can get comfort here. Say twice x by 3 minus 4y whole square. So now here also you try to see this will be treated as a and this will be treated as b, and there is a sign in between, that is the minus sign. This is the minus sign, you can see. So if minus is there, what it means, you are going to apply the a minus b whole square formula. So it is the place for a square minus twice, it is the place for a, it is the place for b, and then plus it is the place for b square. Now go on giving the values input. This is 2x by 3, then this is 2x by 3, then this is 4y, this is 4y. Why I am doing the bracket? Because many a times many students I have seen they write this as 4y square, but remember 4y square and this what I have written are not same, right? 4y whole square should be the correct. So I have used the bracket at the beginning, and I will suggest you to use that same also. In that case, you will never commit any mistake in expansion. This is 4x square by 9, not 3. 9. Then, yes, 2 2s are 4, 4 4s are 16 will come here. Then 3 is down, and xy, and then it will be 16 y square. So that's the answer. That's the answer of this kind. Say number 7. Somebody asks you to expand this, suppose 1 by 2 minus, sorry, 1 by 2x minus, say 3 by y whole square. So here also you try to see, you can easily identify that the first number you can consider as a, this is minus n, this is b. So a minus b whole square is the clear cut formula to be applied. So you apply and apply the trick what I am saying. First you reserve the place for a, it is a square. Then 2, this is the place for a, this is the place for b, and then this is the place for b square. So now a means 1 by twice x, it is 1 by twice x, 3 by y, and this is the place for 3 by y. So now I'm sure that you will not commit any mistake in the simplification. Now you can see there can be some term cancellation. These two can be cut here. So you remove that. So what will be left out with, that you write here. So you'll be getting this here as 3 will be in the numerator, then it will be xy. And then here if you do a squaring, 9 will be there, and below it is y square. That's it. That's it. Next question means it is not a question actually. This is the elaboration of the property what we did. Right? Those properties can be applied. Those identities can be applied in a modified ways. So that also many students have confusion. So I'm going to apply those first. I'll show you how they can be modified, and then we'll be knowing their utilizations. So already first let me just take only one of them. We have a plus b whole square equal to a square plus twice ab plus b square. This is one. So now what exactly I am going to do is this. Just try to see. This twice AB, I want to shift to the left side. This twice AB, I want to bring to the left side. Then there will be a new shape developed. That is a plus b whole square minus twice ab will be looking like a square plus b square. In fact, at last, we would try to remember that a square plus b square will be is a plus b whole square minus twice ab. And please remember, this is one of the very, very important deduction from the main formula. This is not an identity. We do not call it as an identity. It is a deduction from the original formula. It's a deduction, right? So this deduction is very important. We use this as an identity, right? So this is one of the deduction from where? From the formula a plus b whole square. Now, if we can do something for a plus b whole square, then similar observation we can make for a minus b whole square as well. That will be a square minus twice ab plus b square. So here also I'll be doing the same thing. That twice every term I'll shift to the left side. Then I'll be getting a square minus b square here also. Now the greatest irony is that, or I can say that the puzzle the students can get here is that we have got two different expressions for a square plus b square. For a square plus b square. So you can see here a square plus b square, it is same in the left side. Here it is a plus b whole square minus twice ab. Here it is a minus b whole square plus twice ab. So now as and when you will be knowing what value is given, a plus b or a minus b, that will decide which particular formula you have to use. So one quick example I would like to take so that you get it clear. Suppose tomorrow somebody asks you, tomorrow someone has asked you that if the value of say a plus b is 4 and ab is 2, then what is a square plus b square? Now you see, you have got a plus b. So what you have to use? A square plus b square, you have to use the first one. You have to use the first one. That is this thing. So now that will give you the value. This is 4 square minus 2 into 2. It will be 4. So 12, sorry, 16 minus 4 will give you 12. So that is the value. Right. So this is the way how we process the question. So now one more question quickly. It is coming in my mind. So I'm writing it. So just this question is coming into my mind. Right. This is an important question. This is an important question. Mark this. Why it may be like this. Uh, is a plus b equal to 4 and ab equal to 10 possible? Is that possible? Like, is that possible? They are asking you to justify it is 10. See, this is a question of plus 10 standard only, right? Because we do not have the idea of complex number. It will be possible, of course, if we go for higher classes, but I'm talking about plus 10. So in this class, is it possible? So what we'll do is this. A square plus b square will find a plus b whole square minus how much it is with the formula twice ab. That leads us to say this as a 4 square, then 2 times minus 10, then this is 16 minus 20, leaving me at minus 4. Now just you have to justify whether this particular part what we arrived at, is it okay? Is it okay? So that will tell you whether it is possible or not. So now just you justify, try to justify this. I am telling you the justification now, right? So that you can understand. The justification is that left side we have a square and b square. Left side we have a square and b square, and in between plus. Okay, so this a square, if you put any number inside, either it will be 0 or it will be positive. It cannot be negative. Square of a number cannot be negative. Similarly, this number cannot be negative. So in this whole thing, you are adding two numbers which are both positive, and in the result you are getting a negative number. It is not possible, right? So what I can write in the next step, that this is a positive number which is equal to a negative number, right? And this is not possible. It is not possible. That means what we got here, this particular situation, what I have said, that is it possible? That situation is not possible. So this is a creative question, right? That is a creative question. Please just see whether understood or not. We'll be doing problems on these identities together, a lot of problems. Now let us just see that these identities can be given some more shapes. That is very, very important to understand. As one more shape can be deduced from this, that is very important to know. So for example, suppose I expanded this and then I ask you to write the complete expansion. So you have written it like this. Good. Now what we'll do, I will write this as a square minus twice ab plus b square. And then I can write here, in order to balance everything, as plus 4ab. So now you can see, actually I have written the same step. I have written here the same step. This is minus twice ab. This is plus twice ab. Overall simplification will generate me this only. So I did not at all change the target, right? So whatever I was given to it, I have kept it. But here, if you now use the identity, you will find it like this. So what have you understood here it as? A plus b whole square is equal to a plus b whole square is equal to a minus b whole square plus 4ab. This is a very important result. This is a very important result, right? Now, after knowing this, you can also try that if I can start with a plus b whole square, I can even start with a minus b whole square. Why I cannot? I can start. So if I start with this, the same type of things I can write here. I made it plus twice ab, and then what I'll do, I'll adjust it. So what it will give me it as a plus b whole square minus 4ab. So in fact, from the previous only you can generate this just by shifting 4ab to this side. This also is a way, but I did not do that. I have just independently explained you that this can be developed like this also. So you have got these two very, very important deductions. Very, very important deductions. Please remember this. Actually, I am doing it all so that you will never face any problem in understanding this, right? So today we'll finish it here only.